All right, let's get into it. We're going to be talking about a really cool story about where agricultural innovation comes from. And here's a hint, it's probably not from where you think. We're talking about farmers, not just as growers, but as brilliant innovators. So think about this for a second. Who actually gets to create the seeds for the food we all eat? When you imagine a new type of rice or a new kind of corn, who do you see making it? Yeah, for most of us, the image that pops into our heads is probably scientists in lab coats, right? Or maybe some researchers at a big university, or even one of those giant agricultural companies. It's this very top down idea of how new things are made. But what if we could just flip that whole model on its head? What if the real experts, the people who actually have their hands in the dirt every single day, what if they were the ones driving the whole process? Well, that's exactly what we're talking about here, farmers as breeders. The official name for this idea is participatory selection, and it's all about collaboration. Instead of scientists just handing down seeds they've developed, this whole approach puts farmers right at the center of it all. They become the key decision makers, picking out the plants that work best for their land, for their climate, and for what their community actually needs. It's innovation that's super local and super specific. And this quote, wow, it just says it all, doesn't it? It comes straight from the team on the ground in Indonesia, and it perfectly captures the spirit of this. It's all about making science accessible, showing that creating new crops isn't some kind of secret magic that only a few people can do. Anyone can do it, even farmers. Okay, so you're probably wondering, that sounds great, but how does it actually work, like in a real field? Well, it's not just a theory, it's a super practical, hands-on process. So let's walk through the 4 main steps these rice farmers in Indonesia are using. So here's how it breaks down. First up, select and mark. The farmers literally walk through their fields and spot the plants that just look better. Maybe one's a little taller or has more grain, or it didn't get sick when its neighbors did. They put a tag on it. Simple. Step 2, harvest and monitor. This part's so important. They harvest those tagged plants completely separately from everything else. Gotta make sure those special seeds don't get mixed in. Third, dry, pack, and label. This is all about careful handling. The seeds get dried out properly, packed up, and labeled so you know exactly what you've got. And finally, step 4, replant in a controlled setting. You don't just toss these new seeds back into the big field. Nope. You plant them somewhere you can really watch them, like in a bucket or a bag, to see if those great traits carried over to the next generation. Now, this all sounds amazing and honestly just super logical from a farmer's point of view. But I know what you might be thinking. Can an approach that's so grassroots, so bottom-up, really produce results that stand up to tough scientific scrutiny? Can it compete with the big guys? Let's find out. Because this is where the farm field meets the formal scientific trial. The seeds that the farmers picked out, well, they don't just stay in the village. They get moved up to the next level for some really rigorous testing to prove just how good they are. Okay, so now we're getting into the science of it. Check this out. We're looking at an advanced yield trial in Pasir, Indonesia. The F7 just means these seeds are the 7th generation since the original parent plants were crossed. Think of it like refining a recipe 7 times. By now, it should be pretty stable and consistent. And look at the setup. They're pitting 6 of the new farmer-selected varieties, or genotypes, against 2 of the standard regular varieties. It's a real head-to-head competition to see who performs better. And they're looking at a very specific point in time, 90 HST. That just stands for Hari Setelah Tanam, which is Indonesian for days after planting. So 3 months in, the researchers can already get a really good idea of how these new plants are doing, way before they even count the final harvest. And the early results? They are looking really, really good. 2 of the new guys, OS5 and OS6, are total standouts. OS5 has already looked good in past trials, and OS6 is looking amazing in this one. It's showing good uniformity in phenotype, which is just a sciencey way of saying the plants look healthy and are producing lots of stems and grain clusters. And get this, OS5 has an ancestor called Padi Gugu, which might mean it has some natural drought resistance built right in. How huge would that be? But here's the kicker. This is not just some fun experiment. The ultimate goal, the whole reason for all this hard work, is to get these farmer-developed varieties officially registered. That gives them legal protection and lets them be shared and grown all over. It's the ultimate proof that innovation led by farmers can create results that are scientifically solid and officially recognized. So let's just zoom out for a minute. What does all of this really mean? I mean, this is about way more than just a few new kinds of rice. This is about power. It's about who holds the power in our food system right down to a single tiny grain of seed. So why is this such a big deal? Well, it comes down to a few massive wins. First, you've got farmer empowerment. They're no longer just customers of technology, they are the creators. Second, you get crops that are perfectly adapted to local conditions, not a one-size-fits-all solution. Third, this makes communities more food secure by building resilience from the ground up. And finally, it's a huge boost for agrobiodiversity. Instead of just a few big commercial types of rice, this method encourages a whole range of varieties, which makes the entire food system stronger and safer for all of us. So it all leaves you with this one last, kind of powerful question. We spend so much money and time looking for the next big thing in a sterile lab or corporate boardroom. But what if the best, most resilient, most important innovations are already out there, waiting in the fields, in the hands and minds of the very farmers who know the land better than anyone else?